All right, so that's a second order differential equation. What makes it a second order differential equation? It's got a y double prime. That makes it a second order. What you're going to do, for this differential equation, you're going to notice that there are y primes, there are y double primes, but there are no y's at all. There's x's, but no y's. So when you have no y's in your equation, you're going to let p equal y prime, which is dy dx. And then p prime will be y double prime, which, if you prefer, is the second derivative. And you're just going to make those two substitutions. This becomes x p prime plus p equals 4x. And what should happen in this case, that new equation, first off, notice it's first order because it only has p prime. It should become either separable or linear. Notice like I didn't have a 4x y over here.
Okay.
There was no y anywhere in the equation. There were just y primes, y double primes, and x's.
So it becomes linear.
This one, I agree with you, this one is linear because I can write this as p prime plus 1 over xp equals 4. I divide everything by x. This one becomes linear. Sometimes they'll be linear, sometimes they'll be separable. Yes? No? All right. No y is what that says up there, yeah. No y. No e. All right, so rho is e to the integral 1 over x dx. That's e to the ln x, that's x. So we multiply everything by x. We have x prime, or xp prime, plus p equals 4x. We check quickly the left-hand side factors as the derivative of x times p. You can check and make sure it works. It does.
Oh yeah.
Got it? Okay. Integrate the dx. No, integrate. So xp is 2x squared plus c, which means p is 2x plus c x to the negative 1. But we're not quite done. How come we're not quite done? We got to back substitute. P was y prime, so this is y prime equals 2x plus c x to the negative 1. And notice once again we have another separable differential equation because I can multiply by the dx. So you just integrate again. Y equals x squared plus c ln x plus, there's got to be another constant when I integrate a second time. There's a k, I suppose.
Now we need two initial conditions for this?
Absolutely. When you start with a second derivative, to find the exact solution, you're going to need two initial conditions. I didn't give you any initial conditions, which means you're just going to have two arbitrary variables in this case. You're good with that?
George, are we going to ever have to do double integrals?
No, we will never do double integrals in this class. Or triple.
That's good. Okay.
All right, the other thing that can happen, sometimes you have an equation like this one, y double prime plus y prime squared equals 0. So what you'll notice about this equation has y's and it has y prime and y double prime, but what is it missing? There's no x anywhere in the equation. All right, so when you have no x in the equation, you're still going to let p equal y prime, which is dy dx. Then y double prime would be what? If p is y prime, then what's y double prime? dp dx. Take the derivative, right? However, this equation didn't have any x's in it. So I really don't want to introduce this x into the equation. So we're going to use an alternative form of the chain rule. dp dx is the same as dp dy times dy dx. You agree with me that those are equal? Yes, you can think of them in terms of differentials. The dy's would cancel out. But what's dy dx? Y prime, which is p. So y double prime, we're going to substitute with p dp dy. So that everything will have p's and y's. We didn't introduce an x. The equation didn't start with an x. We don't want to sneak one in there. And once again, what should happen when you make these two substitutions, y prime is p and y double prime is p dp dy, once again the equation should become separable or linear. All right, so let's see what this one does. This one becomes yp dp dy plus p squared equals 0. Should be separable. Let's see. Yp dp dy equals minus p squared. So it looks like I can divide by p squared, also divide by y, and multiply by dy, and my variables will be separated. So I'm going to have p divided by p squared. I'm just going to write that as 1 over p dp equals minus, I have to divide by the y, so 1 over y dy. I was able to separate my variables. Integrate both sides, all right. ln p equals minus ln y plus c. Exponentiate both sides. P is c over y, because this minus sign here, this would go in as an exponent. So it's y to the negative 1, so the y goes to the bottom. But again, we're not quite done, because p was y prime, which was dy dx. So now we have dy dx equals c over x, which is again, c over y. Sorry about that, c over y. That equation is once again separable. I multiply by the y, so y dy equals multiply by the dx, c dx. Final solution, y squared equals cx plus k. Over 2. Thank you. Questions on that?